In this episode, I have a conversation with John Austin. John has been on the podcast once before in a roundtable episode where we talked about investing in programming tools and integrating new programming tools into a existing workflow and developing new sort of out there creative ideas about how programming could be reformulated. And in that episode, John mentioned that he is working on a visual programming system. And so I've had him back on in this conversation to talk to him more about his work on that specific tool. Now, we'll get into the details in the conversation about this tool as well, but just to give you a preview of where this is going, John is working on a tool called Lattice. It is a visual programming system in the sense that it is nodes with wires between them, and it is built around some interesting concepts like build graph style of organizing computation, and it has a very serious sort of compiler backend style implementation so that John can actually use this and target C Sharp, which he then can use to integrate into the game he's making professionally on the Unity engine. So it's not just a theoretical idea, he's actually putting the visual scripting system he's building to work in his game studio, which is pretty cool. With that, let's get into the conversation. All right, I'm here with John Austin.
Hello, how's it going?
Pretty good. So I've had you on the podcast once before. That was a group discussion that time. And in that group discussion, we did spend a bit of time talking about sort of non-traditional types of programming as, you know, pros and cons. It was just sort of a group chat. And you mentioned there something that I hadn't known going into it, which is that you're working on a non-traditional programming system. And so I wanted to get you back on at some point to hear more about that. And I will spend most of the podcast getting into that. But before we do, I think there's one other thing I'd like to hear about that sort of will set some groundwork, which is what is your day-to-day work like for you right now? What are you working on? What tools do you use? And what do you make?
Yeah, that's a good question because I do a lot of things. So I run an indie game studio day to day. So it's called Pontoko, and we made a game called The Last Clockwinder recently, which 2 years later we're still somehow managing to do maintenance work on. There's just so many VR headsets out there and so many configurations, and so we just pushed another fix today. So we've got a lot of that kind of maintenance work, although I don't do quite as much of that myself. But my day to day is mostly working on one of our new projects, which we haven't announced yet, which is kind of codenamed Outside Space and Time. Yeah, what we're actually doing on the project right now is kind of building up scaffolding for the game. So we're using Unity and Unity's new entity component system, which is really fast. It's very performant. It's also maybe like 70% complete in the sense that it's like sort of bring your own XYZ. And so we're working on implementing some of that XYZ a little bit, as well as just other tools that we want to use for the game. And one of those tools is the visual programming language-ish thing, programming system that I was talking about earlier, or at least a manifestation of it. I have several versions of it floating around the ether. So for the last, 6 months, I've been working part-time on sort of visual programming and part-time on like fleshing out game prototypes. So like building gameplay and doing design work and building levels, and also doing a lot of talking with my partner, Matt, who's also a game designer and engineer. And so we just have a lot of back and forth about what games do we want to make? What are we trying to do here? Like, and then we go implement something and see how it feels. And then we go back to the drawing board, or we say we like it and move on. And yeah, that's kind of been the process. But because the entity component system is so fresh and so new, there's been a lot of tooling, like a lot more than a standard Unity game, which has its ups and downs. But yeah.
Gotcha. So the visual programming system that you were talking about, I think a year ago when we met, is the one I think you had mentioned you were working on it for a while, even at that point.
Yeah.
So I think you told me at some point that it has a name. Is that something that you're Is it like, is this a project that is at the level where you're talking about it with its name and everything?
A little bit, yeah. And right now I'm calling it Lattice, and we'll get into
Okay.
why I'm calling it Lattice, because there's some interesting structures at play that give it that name. But there are several versions of this, and I don't know whether to call it a language. It becomes more of a language the more I work on it. I sort of call it a programming system because it is not a language in the sense that you need text code to go along with it. There is no code that only is written in visual nodes. That's
Okay.
You're intended to use it alongside programming. But it is sort of a programming language in of itself. It has an intermediate representation. It's like a compiler. It's like got things going on that side. So a
Interesting.
little bit of a fuzzy line. But I've been working on this this system for like, oh boy, it was 5 years at one point, but now I'm realizing it's longer. It's like 6 or 7 now. Like the version we're using inside of Unity is version 3. The first version was in TypeScript. That was like just sort of a slap it together version. And then TypeScript is super slow, so I wrote it in Rust. Rust is great, but doesn't play well with Unity. So I sort of have 2 implementations right now: the Unity one, which we're using in the game, and the Rust one, which is more feature full and fully fledged, but sort of more of a standalone thing and needs more work. And makes sense. But
Gotcha.
it's been a long process. So right now I'm putting most of my time on the Unity one because that's the one that's most. And really, when I say Unity, it just means .NET, C#.
Right. So that's cool because it sounds like you are using Lattice to some extent in the game prototyping phase that you're in, and I want to hear more about that. But I want to focus more on the basics here. So for everyone listening, if you're listening and you don't already know what someone means by visual programming, it's going to be hard to fully give you the idea from scratch. But I think there's a couple of different instantiations that even someone who has spent time in the space might be aware of. So can you give us an idea of like what kind of visual programming is Lattice?
That's a fantastic question because I have a lot of opinions about visual programming, and I think I'm kind of disappointed with a lot of visual programming in general because I think it often gets skewed for pretty much just beginners. Like if you look at a lot of visual programming languages, they start off really hot and really cool, and then at some point they kind of just like pivot off into like a beginner tool. And I'm kind of frustrated by that. I think there's some good reasons for that, but one of my explicit goals for my language is to make a visual programming language that I would use as someone who has like nearly 20 years of experience programming. Like, what do I actually want to use? And it needs to do something more than text can. And a lot of what is this sort of like what drives me is I have this like strong feeling that text-based code is a local minima. Like there's a lot of good reasons to use text to represent ideas.
I'm gonna pause here to just make sure you said local minima, and I want to make sure I'm on the same page with you about what you mean by that. Local minima, as in it's like an optimal point that is optimal in its region, so that once we started text programming, making the shift out of it is difficult, but the locality part is important because you're saying globally there's probably much better stuff out there, but getting there requires going downhill first or up. It's confusing because you said minima. I think you mean like optimal in some sense.
I guess if you're talking about optimizing or if you're talking about maximizing, depends on
right
sort of what it matters. But yeah, that's exactly it. Like basically, like we've perfected this form of, or well, not perfected, but we're really deep entrenched in this form of text-based programming, and it is really hard to imagine another form just purely because you have to make a lot of other tools. I mean, like just GitHub, like diffs, like everything we do is text, and so
the command line,
right? And so if you want to make something like a visual programming language, you do need to set a lot of groundwork. Or, which is kind of the approach I'm taking, you need to build it in a way that integrates with text, with those tools.
Okay.
But doesn't necessarily need to be edited in text. And that's kind of, we can talk about that more. But that's the sort of local minima that I was mentioning is kind of what I'm frustrated about. Is like a lot of visual languages will like inch their way up the slope and then slide back down and sort of become like let's teach people how to code kind of thing, because they
Yeah.
sort of lock on to like what is working, but they just don't push it far enough in my opinion. And
Yeah, so can we we'll definitely get into that. Can you give us the intro to what kind of visual programming Lattice is?
yeah, so Lattice is based on uh, it's it's more like a build graph. So I have this blog post in the works. It's called "Build Graphs Are the Most Beautiful Form of Computation." And what I love about a build graph is a lot of really cool properties. So by build graph, I mean something like Bazel, or really any compiler that where you've got this big directed acyclic graph of things that are being compiled or built. And what's neat about a build graph is every node declares its just the data that it needs, and the execution engine kind of figures out how to execute it, which is interesting because it means that just imagine that the build graph was like more like a computational programming environment. If I have an error on one node and it's like, oh, this node couldn't compile, what happened? Well, there's only so many places to look. There's sort of like a log n number of nodes up that graph that you can sort of look at, and one of them is going to be the failure point. So you have a finite number of places that error could be, and then also all of the nodes are static. Like the data in them it's not going anywhere. You don't have to like catch it in the way that like a debugger, you have to like sort of catch the value when it's broken. The errors are right there. So all you do is you sort of walk your way up the node tree, and you're like, oh, there's the error. Okay, why is it doing that? And you can fix it. There's like this concept that I've been sort of trying to verbalize in my head called like values you can hold in your hands. I don't know if that makes any sense, but I feel like when I'm debugging text code, like half of my time is just spent trying to catch the thing. Like you're just trying to line everything up in the right scenario such that you can replay that bug. And a big part of Lattice is treating programming more like a build graph, where values only ever execute once, and you can look at them and you can look at their inputs, and they don't move. They're just sort of like it's a computational build graph. Does that kind of make sense?
Yeah, I'm gonna cover that ground again, maybe a couple times to make sure I got all the pieces right, but I think I have a basic picture. So when I'm thinking of a DAG where each node declares what data it requires, and then that node represents some of the computation that has to happen. I think that clarifies it. I sort of start to build a mental model of inputs, and I think like the way my brain spatially wants to organize this idea is that inputs are kind of arranged in a row at the top of my visual field, and then computations exist farther down than their inputs. And so I can imagine that there's time kind of flows down through this thing, but it never, when you're talking about the fact that you don't have to catch the moment when something happens, it's because you sort of when code executes, time flows sort of down, but then there's sort of replay, like we can loop or we can call a function again. And so I just recently had a bug where the bug appeared was very easy. It was very easy to find the spot where the bug appeared, because I could just sort of put a breakpoint when it was hitting the condition that was nonsensical and was going to crash. But to actually understand the bug, what I needed to do, what ended up being the key, was to walk through that code path on the previous time it got called, because on the previous time it got called, that's when it worked, but it then corrupted the state, and so I needed to figure out, how am I going to see the previous run of this path and see what's happening there before I could realize where the bug was. And you're saying that because it's a DAG, I'm imagining it's the kind of execution path where each node only ever happens once, and it can happen whenever all of its dependencies are ready. And so if there is an error, it's not that there can't be one, but if there is one, it's not like you have to figure out when you don't have to catch it in time. The time is sort of I'm having a hard time putting words on it, but I think the visualization of you go up the chain to a point where the thing stops looking the way it should, and that's how you know where the error is, makes intuitive sense as I sort of visualize it.
Yeah, that's pretty accurate. Um, there's we'll get in. So there's time is a really good thing to be talking about because probably one of the things you might note about the system is that like, well, time is valuable. Like loops are useful, and so like what makes Lattice interesting is how we recover some of that value without actually looping. And that sounds very, as I'm saying it, that sounds very abstract and spooky. But that's one of the main challenges. Is like these build graphs are so useful, and having all those properties you're describing, sort of being a-timeless. Like they don't really have the nodes can just execute whenever. Like you can just whenever their input dependencies are ready. But yeah, I'm stopping myself before I leap into the next topic. But you're spot on. Yeah.
Awesome. I think that's pretty clear. I want to traverse it one more time in a slightly different way, which is just sort of forgetting the computation model for a minute. Just paint me a picture. If I were to look up screenshots of what this is, what does it look like?
It's almost precisely what you described. And in fact, that's kind of my goal, is to make it feel like you got nodes that are values. They're immutable values. And there's lines that go to other nodes that are other immutable values. And the precise, like, there's a lot of like visual representation questions, which I would equate kind of to like syntax questions in a normal programming language, which I'm intentionally sort of dodging right now because just like I think you should dodge that when you're building a programming language to start. Like you can get hung up on the prettiness and the visuals for ages. I think far too many visual languages get hung up on that way too soon. So, but that's the general sense of it. Is like, yeah, you can move around in this sort of 2D space, but it still reads top down like text. So, nodes at the top are, maybe you have some like literals, like a string or like a 5, and then those flow down kind of into computations, which flow into other computations. And
excellent. Yeah, I can absolutely picture it. I hope the viewer or listeners, not our viewers. If we had viewers, it would be very different.
Yeah, maybe we can do a YouTube one at some point, and I'll show you.
Yeah. So let's move on to another aspect of sort of getting used to the core design ideas here is when you are designing this. You already mentioned it a little bit, and I want to get into it further, which is the question, who is it for? And the piece you've already shared is you don't want it to be for beginners, right? You want it to be for someone who's experienced. But you've also mentioned that it has to include a certain amount of text. So I guess when I ask who is it for, what I maybe am more interested in knowing is what if you are on a small team and you have to do multiple jobs, which jobs are being handled by Lattice?
Yeah. So let's separate the two implementations of Lattice. So there's the Rust one, which I consider to be a general programming environment where the nodes themselves actually, like, I'm designing it such that the nodes could be implemented in different programming languages. So you could write one node in Julia and one node in Rust, depending on what you need. That's one version of it. But like, let's set that aside because that's sort of like the abstract general best version that I want to make. But the one I'm making in Unity, which is C#, basically, the role it's filling is, for us, it's mostly filling the role of glue, is the way I would describe it. So when you're writing code, I often find that I'm in two mindsets. One is like, I've got this like really well-defined problem. I've got some data. I need to turn it into something else. And I'm mostly just writing lots of code. You have lots of like if statements and like little for loops and like implementing an algorithm, something like that. You've got that kind of work, which I think is still way better suited to text, especially math. Like if you're doing math, like, oh my God, don't do math in a node language. That's just the worst idea ever. So you have all this stuff that's like kind of the nitty gritty is in text. But then you also have like the architectural level of code where you are connecting all of those little bits together. And there's tons of different ways to do this. Like object-oriented programming is like one of these ways. And So Lattice on our end sort of fulfills that like connecting stuff together aspect. So it's like I will write a little function that loops through all of the characters nearby and finds the closest, like a sort of a seek to the player kind of function. And that can be just a normal C# function. And then I can take that and make it into a node in the node graph so that when I'm stitching together this new like charging enemy AI, I can drop in a node that's like, okay, I've already written this before. Okay, I'll drop in like a find player node, and then I'll drop in like a charge kind of movement node, and kind of I can do all my gluing together in this more of this like visual space, and then go and write the actual logic in C#. And sort of more specifically, we do that a lot for mostly gameplay code and like setup and stuff like that. But I can dig into more game dev stuff if you want.
Yeah, I think that's interesting. So a couple of things in there are interesting, and there's a lot of stuff coming up very quickly as we talk about this. So I might miss some of the cool
No, that's good.
branches this could go down. But you have some strong opinions. It sounds like that to some extent. Yeah, I'm gonna hesitate to fully agree with them just because I don't want to change where things go, like where you would take them, or to fully disagree with any of them. But what I do think is like a lot of people who, or not people, a lot of existing visual programming systems that I have seen don't quite sound like what you're saying. Like the it seems to me like when I've looked up visual programming things before, they're kind of coming at it like just like when I go to look up how do I start programming Python, it's like day one, hello world, day two, here's how you add integers together. And I feel like you're saying that is not what day one of visual programming should be, because you are never adding integers together in visual programming. So I guess I'd like to hear the other half. The other half that is interesting is that you're saying it's effective at the glue code part, and I think that when I imagine what glue code is like, I imagine like you're describing algorithms that do, maybe they're more difficult actual logic, like locating a path, like A* to find a way to get to the player, is sounds like the kind of thing you're saying like, now put that in your text code, because all the little finicky details and the ifs and the loops for figuring out the grid probably easier there. But when we go to figure out what to do with the information from A*, now we're gluing things together. And I feel like I get what you're saying, but it sounds like it's, and maybe you'll just agree with this, but it sounds like it's entirely intuitive what counts as high level enough to go into the visual system, or like worth doing through visual means, and what counts as like, no, that's lower level and or too finicky or too mathy. So do you find that it's really easy and you tend to make the right calls, or do you have any examples of like stuff that you wrote on one side of the barrier that was kind of like, oh man, this is the aches, it kind of belongs on the other side in some ways too? Or what do you think about that?
That's a great question, and it's something that I have been very excited to be figuring out, like now that we're using it in the game. So I don't have a solid answer for you, and it's really just depends on what you're doing. One of the things that's so Lattice being a DAG without ifs, not without ifs, it does have ifs, without loops and without recursion, it's very limiting. So already there's kind of a whole slot, like kind of just a whole bunch of code that you couldn't write in Lattice. Like in fact, one of the weird things about this system is that one of its strengths is that it's not Turing complete. So a DAG itself, a computational graph, is not Turing complete without looping.
Mm-hmm.
But that's actually its main strength, because if it's not Turing complete, you can actually do a lot of analysis on it that is not possible on normal code. So for instance, you can the lattice graph or whatever, computational DAG is provably terminable, like as long as all of the nodes terminate. But like the graph itself totally terminates. You can propagate all sorts of weird information through it. So the compiler does a lot of like analysis on the graph that it can propagate very easily because of the non-Turing completeness. Like for instance, you can do automatic parallelization on this graph. You can do automatic incrementalization. Like these sorts of things that are like kind of really like far off dreams of text programming are like actually very easy in a DAG space. So that kind of split is very intentional, in that like you want to do as many things as you can in Lattice, but you don't want it to be fully Turing complete. And then everything else that's kind of like you need something a little more complicated, you put it inside the node. Yeah, I don't know if there's like any like rule or logic to it. I think it's kind of like any other text-based architectural choice. Like, where do you draw the line between your abstractions?
Well, yeah, absolutely. I think I haven't built the sort of thing you're talking about or worked with one. I've toyed with existing visual systems here and there, but I've never worked on a real project that was either hybrid or made any kind of heavy use of visual programming. But the thing I have done is I've done projects where I had like my C layer and my Lua layer, and I definitely know that once in a while you get into situations there where you start writing something in Lua, and then after a couple weeks you're like, this is getting to the point where it was a mistake to do it on this side of the boundary. And so I guess I was sort of looking for if there's a similar problem that comes up, or it sounds like partly some of it solves itself because Lua is Turing complete. I can start to fall down the path of imagining putting anything there. Whereas these limitations, it's like, it's never going to do the loop over it's not going to do a convolution for you because that's too much math and looping. It's such a wrong fit that I wouldn't make the mistake.
Exactly. That's exactly it.
Right. Yeah.
It's very similar if you ever used like a MapReduce system, like Beam, or like Google's got their own thing too, but like where you're writing like little chunks of computation, and then you stitch those all together in this big graph that runs in parallel over lots of clusters or something like that. And yeah, it's a similar thing where it's like, well, that graph isn't as powerful, and so you don't really end up going down that path very often. Like, I don't find myself writing things in Lattice, quote unquote. If I find myself dropping lots of nodes, I'm already like, oh, this is probably too many nodes. Like, let me clean this up a bit, and I find that usually works a bit better.
There's a couple other things you mentioned about opinions on visual programming. I'd like to go back and touch a couple of the other ones. So you mentioned that a lot of times they pivot into being a beginner tool, and that it sounded like maybe you had some thoughts on, like you said, there's good reasons for that. I'm curious, do you feel like you've identified in that case a way to avoid going that route? Is it just because it doesn't do everything, or is it because where along the way has your development process diverged from eventually hitting a wall and pivoting to beginner tool?
Yeah, it's a deep question, and I mentioned it in part because I don't really want to like degrade the beautiful history that is like visual programming language design. Like there's been an incredible amount of work by very smart people making visual programming languages, and it would be beneath me to be like, these guys, what are they doing? Like, that's ridiculous. So I think the challenge is that when you're building anything, you're sort of following the excitement a little bit. And one of the most exciting things about a visual programming language is that it's very approachable to more people. Like, no matter who I show it to, I can show this to our artists on the team, and they're like, "Ooh, I want to use this," and I'm like, "Look, you could learn text. Like, I swear to God, you could learn C#. But there's something about visual languages that just attract people more so than text, and I think because of that, and then also because of how hard it is to make enough feature, like a good enough programming language to mirror like anything useful on the text side, like it's very easy as a designer to like sort of chase that excitement, because like look, this is where everyone here is like shouting, "Yay, you're doing a good job, follow me!" Like, and it's also like it's hard to not feel like it's one of the strengths too. It's like objectively, visual programming languages, one of their strengths is like getting non-programmers to use them, and so one of the things that's kind of a tricky thing to navigate is like I kind of feel that I need to break that branch off and like say like, okay, I'm not going to worry about beginners because I need to focus in on making this good for me first. My hope is that like eventually I'll circle back, and it's like once I have the groundwork and like the sort of more like formal model that this whole thing is like operating on, then I can go back and sort of like work in, okay, well, now how can we make this more easier to use and expose this? In my opinion, the way that Lattice works is extremely simple, and like that's one of my favorite parts about it. But I'm trying not to. I don't know, like, yeah. I've also just seen so many visual programming languages that are just really interesting, but just not useful. Like, I don't know, man. Like, I don't.
Yeah. There's still so many interesting branches that I want to keep exploring here. The another thing that occurs to me listening to that thought process that you just gave us is if you're right that there's like this tradition of these sorts of things being about bringing in people who would otherwise bounce off of the programming skill. Like it's about, and in fact, I'll even say that when my first introduction to programming, it wasn't visual in the sense that you're talking about. It was like a drag and drop sort of procedural command thing where you could take these little visual commands from a palette and drop them into a thing.
Yeah, I used the
And
Lego Mindstorms code editor at one point.
right, and
Yeah.
so there's accessibility for people who are younger. There's also accessibility for people who are gonna more easily bounce off of like walls of text, but who find visual things engaging enough or intuitive enough to deal with. So that's like a clear, strong tradition of what they're for. And it makes me curious that if that's not what your thing is for, why do you think it's useful? Like, how is it to you who could just write glue code?
Mm-hmm.
Is it really that much better for you if that's who it's for? Like, what do you see what I'm kind of getting at?
Yeah,
Like,
yeah, no, that's a
you're
good
saying
question.
you're saying this is the obvious thing it's for, and this is not what my tool is for. So how is what is even what is
What is the point?
yeah.
Yeah, as we're talking about this, like the reason I got into making this is not because I sat down and said I wanted to make a visual programming language. Like that was not the goal. What I was excited about was I really like build systems. Like if you go to Google and use Bazel, or they call it Blaze inside of Google, and you compile a Python script, under the hood it goes and recompiles Python. Like the build graph is like millions and millions of nodes, and that means like the team working on the Python tooling can make a change, and then just seamlessly everyone's code suddenly integrates it and rebuilds those. And part of what I'm excited about is just trying to imagine normal computation like build systems, because all of those properties that I was mentioning, where you get like the ability to hold values in your hands, like just finding
Mm-hmm.
that error, or like automatic parallelization, remote execution, perfect caching. These are all things that build systems have. Like when you go to compile something, it just downloads the cached version. If you like, don't go recompute it. And part of this is like, how can we imagine normal programming more like a build graph? And that led me sort of inherently to visual programming, if only because nobody likes stitching together build graphs in text code. It's like
Okay.
it's kind of the worst. Like I don't know, it's fine, but it's kind of not ideal. And when you have this ability to like hold values in your hands, you kind of just want to see them when you're programming. Like you can just be adding nodes to the graph, and the nodes just go boop, they pop up, and that's the value. It's right there. You don't have to hit run. You don't. It just sort of shows up for you.
Yeah. It's sort of you've gotten rid of the the edit build run workflow and kind of integrated into one. So if I'm understanding correctly, I think is what you're saying. When you're in the Lattice editor, you put down a new node and hook it up so it's got all of its data. Then the result of that computation just shows up visualized onto the screen
Just immediately,
on
yeah.
the node. Yeah.
You don't have to
That's
like
cool.
rerun anything. Yeah, that's exactly it, and that is really cool. I don't know. I'm chasing that thrill.
Yeah, no, I think that actually answers the question. Like that is what makes it better for you, even if it isn't accessible to beginners. There's text code does have this problem where you are staring at the code and then you do a phase transition where you go into the debugger, and the best the debugger does is still have you stare at the code and then like give you little tiny snippets, or maybe if it's a good one, grab a piece of data and visualize it for you. But a lot of times it still has this disjointed feel of like, okay, now that I figured out where the bug is, I am manually carrying that information back to the code and staring at the code, and now it sounds like you've integrated it. So the code is this directed graph that you're manually directly constructing, and the data is sort of materialized in the same space as you work with it.
Yeah, exactly. And theoretically, you could write a text editor for the Lattice like computational graph. Like, there's no reason you couldn't. I just think it's a lot easier when you've got it all there, especially because there's like not a lot of node editors out there with like hotkey like Vim bindings. Like, that's one of my personal goals, is like Vim bindings by default. Like, yeah, there's graph editors could be so much better. Like, they're just really not. Like, mouse dragging nodes and edges it's just not that great. But I actually think that just the node editor just is the nicest way to edit a computational graph, and I'm sort of pushing on that.
Gotcha. So I'm gonna move on. I do think we'll come back to at least that last point, because there's a lot of interesting stuff to talk about in terms of the making the editors good. Before we get into that, I want to talk about a different aspect of the project. So can you take us to a time when Lattice didn't exist and your ideas were brewing up, and then it started? Like, what was going on in there? Where did these ideas start?
I have a very clear memory of the first ideas for Lattice. So this is back when I was at Phenomena, and for one reason or another, the projects there were kind of slow. Like, Phenomena eventually kind of shut down. You can go read about it. It's fine. But while I was there, the project were a little bit slow. And I remember going to a conference, I think it was GDC, and I was like really bored at the conference. But I had a lot of time to think, just because I was sitting there in some talk. I don't exactly know what it was. But I was just fascinated by this like concept of imagining a game engine as a build graph. So basically doing this transformation where if you really like rework your imagination of a game engine, you can imagine that it's actually a lot like a build graph, where like frame 5, like the output of frame 5, has as an input frame 4, as well as some inputs for that frame, maybe like joystick movements, time, what have you. And the output of that frame is, an immutable value that basically describes the rendering of that frame, where things are, textures, whatever. And if you lay that all out in a big graph, then you can start to do weird things. Like, you can be like, this node here, let me tweak some values on it, and hey, just recompute like everything in the game, like up to that point again. So you can imagine sitting yourself on frame 45 and cranking some properties, and like the entire game just like recomputes, bloop, like kind of just as you're tweaking things. Or you can do weird like computational sort of queries on this data, where like imagine that you take it. So if you've got all these frames are nodes in this graph, but maybe also there's like nodes inside the frames or something like that for the individual logic. But you can imagine a node that sits outside of time and depends on all of the like frames for like, your player's position, right? It depends on the player position from frame 0 to infinity or something like that. Like all of those nodes. And that is something that you could collect as a single value that is actually immutable in a weird sense. And just you could render this to the screen. So then as you're cranking those values, you could see like the trajectory changing, and that would sort of just recompute for you. The tricky business with all of this is that what I'm describing here is an infinite graph, and that is the fun of Lattice, which is why it is called Lattice, because the structure of the computational graph within Lattice is an infinite graph, but it's an implicit infinite graph, if that makes sense. So you're not actually having to create nodes and stuff like that, allocate or whatever. It only exists at compile time, and it implicitly knows, like, you can do things like, I want to depend on the node one frame before me, and it is aware of that and able to keep the data around, but it doesn't like actually like build a big infinite graph, if that makes sense.
Yeah, interesting.
This is how I got onto it. It's yeah.
Yeah. So you're imagining what if we reimagined a game engine as a build graph? And I think if I'm gonna walk over the same territory real quick to make sure I followed that. The key idea here is usually you think of like a game loop, and in a game loop your job is to you've got some your game loop like is there's some input from a user, joysticks, keyboard, something that is visible, and there's a bunch of state, and it's your job to produce a frame, and whatever state changes are appropriate, and that's sort of how you think about it. And you're saying yes, that's true, but we could think of the state. We could keep the input, the user input as literally input, change this state that we're changing into two pieces of immutable state, the before and after, and the graph in the middle, the build graph shows up to explain how we went from one to the next. And if you imagine then that like yes, for any given like my like low level brain then goes, okay, yes, that makes sense, but I'm gonna have probably a thing now where I throw away the old state, and each frame, like if I was literally building the frame loop, I'd have two immutable states, and I'd construct the next one from the current one and the inputs and some really interesting logic that makes a game. But I'd still throw away the old state. And you're saying, yeah, you can think of it that way, but you can also just think of it as like a frame is this graph, and each frame is a repetition of that graph sort of stacked across time forever.
Yes, got the handle on the general idea. The unique part is that it's more like it's unrolling that, so like the graph into like legitimately like an infinite graph to the right, going to all the way to the right. And so you could point at any of these nodes at any point, and you could say, I want the value of the player's position at frame 45, and Lattice would tell you, okay, that's going to depend on the player's position at frame 44 and 43, all the way down to 0. And it can it can compute that like dependency graph. Does that sort of make sense?
Yeah, I'm following now. So if I say I want the player's position at frame 45, it locally nothing is infinite, right? So locally that depends on the player's position at frame 44 plus the joystick, right, at frame 45. But the player's position at frame 44, then when we look at what does that depend on, it's like it's this sort of recursive. I don't want to say recursive because it's not a recursive function call, but it's self-referential, so that it kind of implicitly goes on forever. Except in reality, there's a frame 0 and it terminates at an initial state. But you could, in theory, no matter how big the number gets, this keeps working.
Right, and one of the restrictions on Lattice is like referencing things between time needs to sort of have a closed form, kind of. So you can't just like reference literally any node, because like, yeah, what if you referenced like player position 1,000,000? Like, what are you gonna do? Like, go recompute? You could, I guess, and it would like go walk backwards. But for the most part, you like things like n-1, which are you can computationally terminate that, right? Mathematically speaking. This is kind of sloppy, but the more important part is that is how it works, and the trick is how do you execute that in a way that isn't slow, right? Like,
right.
And sort of the stuff that I'm playing with is finding ways to analyze this graph to compile it in ways that are fast to execute. If that makes sense.
Yeah. So all that makes sense, and I buy most of it, except that if I were to sit down and write a game, not thinking of this, and then show it to you, I would use if and for loops, which I don't know how. Like, I don't know how. Well, I can, in theory, if my frame is literally the same every time, see how this works. it feels much more likely that I've written some code in there that I'm gonna have to puzzle about how to reimagine what that means if it's a like graph, right? And maybe this is leading into to what extent in Lattice do you give up something that works like an if or like a for loop?
Yeah, there's definitely restrictions. I think I found that they're not as bad as you'd assume because you can always do it inside a node. Like at the end of the day, push comes to shove, throw that if statement, so first of all, you can't have if statements in a node graph. It's called a switch node.
Okay.
But loop, say, you can put that loop in a node, and like as long as you can imagine some output for it that is sensible, like you just do that loop within the node. And for the most part, I found that that's perfectly fine. I'm trying to decide how deep to go on this. If we had a visual representation, it would be a little easier to draw out some pictures. But there are ways, in the same way that time. So we've talked about here how time is represented in a lattice graph by like stamping out the frame over and over again into infinity in your head. That's kind of how you imagine. That's the true form of the graph, right? And that concept is generic in lattice. Time is not special. Time is just an infinite array of numbers. So you can also kind of do things that are like loops by doing that same stamping behavior within a frame, if that makes sense. So if you had like 15 soldiers, you could sort of do a similar lattice. You could open up a lattice kind of one for every. It's basically a map operation. That's the way to think about it in some ways. It's like you've got an array of soldiers coming in and you split out and you do the same thing for each one.
Right.
You could do something with that data. So what I'm trying to say is that don't have as many issues as you might.
Yeah, for loops in some senses are pretty easy. I think like if I just have an open-ended for loop in my logic somewhere, that's where I feel like there's like the term. Yeah, that's a little bit of
at all. Yeah, but honestly, like it just doesn't come up. Like we've been messing with this stuff for a little while, and maybe this is just the nature of games. I actually do think this is not a computational system that's necessarily suited to all things. It's very suited to things that are like lattice-like in structure, where you've got this like frame. It's like a simulation, right? Some kind of structural repetition. And it just seems to happen that games work really well here. It's like usually you've got some input, and that feeds into some logic that calculates a value, and maybe that value affects something else, which then eventually goes into physics, and then physics runs, and then you've got this. Most game engines under the hood are job graphs in some form or another. So, it may just be that game engines are very suited to it. I'm not sure.
Yeah, it's interesting. So I want to clarify something that I've just realized I don't know for sure about Lattice from what we've discussed so far. I know it's a hybrid between your traditional text code and the NodeWire visual programming system, but I don't know, and I know that there's like, it sounds like there are just sort of common cases where you go, no, that's text appropriate because it's got an open-ended for loop, or it's a for loop that I just don't feel like trying to build a map thing for. So just you stick that into you implement a node with some text code and then plug it in, and that'll be easy. What I don't know is there's sort of two different ways I could imagine the way that this is all architected, and a part of how this is interesting is I don't know enough about Unity to know what role it's playing, because it is a third actor in the relationship, at least as it works in a Unity version of this.
Yeah.
But whenever you have a system where there's boundaries, right? So like if I'm going to go into the C Lua example because it's familiar enough to me to like sketch this out. Whenever there's a boundary, you can sometimes wish this isn't true, but sooner or later, like when it comes down to it, one side or the other owns some interesting things. Since you don't have open-ended loops, surely the text side owns the main loop. Now, in the case of Unity, I imagine Unity actually owns the main loop.
Yeah, exactly. That's true.
But it also sounds like you think about Lattice as being aware of, like it's like its inputs in one frame are still connected to previous frames. So it's, even though is it true that how much of how much of your game, this is the big question, how much of your game can be written in Lattice? Is it mostly Lattice with details filled in by code, or is it mostly code with the absolute highest level, like entity scripting kind of, like, do I have a tree of text with Lattice fruit, or do I have a tree of Lattice with text fruit, right?
It's a little bit like a Lattice sandwich is the best way to describe it, I think, personally. So you've got all of your little nodes that you've written, and these are pure functions, basically, because they operate on inputs, they spit out some outputs. They're mostly pure. They can log. It doesn't matter. It's fine. But they're roughly pure. So those are all your little leaves. And then you hoist those up into a big lattice graph, and you connect them all together. And then at the top, there is, maybe you could call it like the kernel or the harness or the system, whatever you want to call it. There's something that's driving the lattice graph. Something that's saying, what's the value of that node? Like, hey, get me all of the renderable things in this frame. Or like, hey, time has moved on to the next step, like that kind of logic. You need something that's like pulling values out of the lattice graph, because without any kind of system pulling out, then it's not going to do anything. And that's kind of Unity in the Unity sense. It's pumping the lattice graph essentially.
Right.
Yeah. But
yeah. So to make the analogy to Lua, this would be. It fits together nicely. This would be where, if you're using Lua, you can at first you can just use it. So use a Lua command line program to run your script. But then you go, oh, actually, the really fun part is I write a C program, and then I have some of the decisions are made by Lua, and so I run a Lua script for my C code, and then I read some results back, and those scripts then become like configuration control things. But then the next step after that is you go, oh, I'm going to have the Lua code actually have access to some of the C functions. And so then I can write some like big data transforms and have the C script the decisions about how to put together the big data transforms. But you end up with a Lua sandwich in this case, right? But it sounds like the same sort of thing. You have hanging at the bottom, you have driving the system, you have some code in one system. You have the text code, and then a lot of high level decisions are getting made in the scripting / lattice space that is being driven. And in order to actually have things that do the most interesting stuff, in order to have direct control over, sort of, what's the word I'm looking for? In order to have a handle that says, I want to now execute this algorithm, but you don't want to write that algorithm in the scripting space, you have another piece that goes back out to the text side, right? It sounds like it's the same structure. Right?
Yeah, and I think that's pretty accurate. The difference with the Lua case is most situations like that, you could have loops, like where the Lua calls out to C, and then that C calls to some more Lua.
Yeah.
Right. In Lattice, that's not true. You can't. Yeah. You can't suddenly in any C# file just call into Lattice. Not allowed. Lattice
gotcha.
is defining the computational structure of the overall script. Lattice is definitely, I would say, the trunk of the system, and the C# is mostly hanging out there as the individual nodes that are being implemented. And then you've got maybe like the fertile soil is the underlying C# running pumping the lattice graph. I don't know.
I follow now. Yeah, I follow. So that means like your highest level game logic, like when you go to describe or to point to, here's what we do on a frame, that's in Lattice.
That's the goal, yeah. And for our game specifically, so the what I've been calling Lattice Unity, that's, I don't know, Lattice.net, I don't know, something like that. That version is a little dumbed down. It's sort of more pragmatic. It's fitting into Unity's boxes that you need to check off all the boxes. And so it functions like that, but there's still a lot of stuff we do outside Lattice. Like we're not trying to do everything in Lattice in this game. Where we've got to finish a game. The Rust version is much more the like, let's do everything in Lattice. But with the C# one, I'm trying to be pragmatic, and we mostly use it for gameplay. Maybe the right word is business logic. So you can write a bunch of different components and then like be able to stitch them together. Like, oh, let's try an enemy that like does 2 charges, and then he locks on to the player and does this other thing, and being able to stitch that together really quick, or like I want to throw together a door that opens when this other thing this button is pressed, like that stuff, like player control, like how does the player move when they have this spear that allows them to bounce off walls, like how do you organize that? And that's also the kind of stuff that's like really annoying to write in text code, because also it often also like involves working with assets, which if you're not super into game dev, like one of the annoying things about game development is sometimes you just need to talk about things like images and animations and game objects, and referring to those from code is really annoying, because you're sitting there like, I guess I'll give them all names, but names are very fragile, so you don't really want to do that for various reasons. You can give them GUIDs, and anyway, none of it's really great. But when you're in a visual language, you're like, oh, I need a texture, drag and drop, like it's right there. Like I just pick, you just pick a texture, and so like a lot of it is like this stitching together that you have to do in a game, like kind of being able to like pull in assets and pull in code and behaviors and like stitch that all together to form the actual game we're making.
That is, yeah, it is interesting. And like a part of what I find challenging about like imagining this is there's the as I said, I'm holding back some of my cards here, but I'll go ahead and reveal that I have a strong preference for a future where text programming isn't sort of the singular dominant approach to controlling the computer. But when I picture trying to, like, when I hear about or think about the sort of thing you just talked about, which is, hey, in text land you have to do this annoying stuff of like giving things unique names to link them up, or giving them GUIDs, or coming up with some way to over here label a thing and over there label a thing and make sure they match and line up and keep them matched and line up for as long as it's correct, and break it only when it's not. It's like, that's a lot of work, and I would love to see a world where that goes away. And I can, on the intuitive visual side, I'm just like, yeah, you're right, you just drag the wire, it should just like, it should sort of just expose directly which things are connected. But then there's another part of me that goes, isn't, does the problem really go away, or does the problem get moved somewhere? Or sometimes it feels like there are problems which, when you try to solve them, what you've done is you've just relocated them. And whenever I've tried to play with things that are like, I'm not going to have unique IDs. A good example of this is if I'm building a UI system and I think to myself, the worst part about this is I have to come up with a way to give everything a unique ID, every button a unique ID, no matter what combination of panels are up. And so what I would love to do is just say like, no, just count them. The first button is button 1, the second button is button 2. It can be automatic. But if the panels can like exist side by side, you get into this problem where it's like, well, button 7 just became button 6 because the panel on the left doesn't have seven buttons anymore. And so like, yeah, you sometimes tricks that I do that should make that go away don't. And I'm curious if you have any insight as to why it does go away for real with the node and wire thing.
That's a really interesting point, because I don't think it totally goes away. I think this is a situation that's very unique to game engines specifically, because one of the things game engines provide under the hood is a system of naming. So like Unity assigns a GUID to every asset by default. The main problem is text doesn't have access. So there already is a system that does this for you. And the main problem is that text just doesn't have access to it. Or if it does, it's not very readable to a user. Really, I mean, you can imagine a world in which your text editor just gave you a drop down when you like, okay, I want this asset, and it like actually lets you select from a picker or something. That would also be sufficient, just as sufficient. And so I don't think that Lattice is doing anything spectacular here in terms of fundamentally changing how that asset referencing stable ID system is designed. But in the context of a game engine, it allows you to bring the code closer to the assets, which, and honestly, this is just a benefit of general visual scripting, nothing to do with Lattice. It's just like the other visual scripting languages in Unity have this benefit too. You can just drag and drop stuff. But honestly, it's not a very interesting question because that's really more of a pragmatic problem. Like, to me, that's not like there's no architectural question there because it's just like it's really just a matter of getting around Unity. The fact that Unity doesn't expose this to text easily.
Yep, I think I follow now. So the thing I was imagining isn't quite a problem here. The problem isn't one of trying to figure out a way that stable IDs are going to be stable and not wanting it to get out of hand. The problem is we already have stable IDs, but the interface to getting at them is poor in the text setup. Yeah. And yes, there's this game that people play whenever you are saying, I want to get past textual programming, I want non-textual modes of programming. And the game is to say, well, you could imagine a text editor that automatically visualizes the same thing. And it's like, there is a problem with that game in my mind because I've written a text editor and I almost can't imagine it. I'm like, what do you mean you can imagine it? Like, you can imagine what it would look like visually, but how do you imagine it actually is possible to do that? Because it's really a lot harder to do it that way than it is to have a box on the screen and say, this box is linked to that ID, draw the texture, right? Like, I have an XY position on the screen and a GUID. That's where the texture goes. You have a GUID reference somewhere in your buffer. Where does the texture go? That's a much more difficult problem, and no wonder we don't actually have tools that do that.
I've played with so many tools that give you that kind of stuff, and it's also just really hard to merge that kind of information with text. Like, I'm barely comfortable with like inlay hints in like text editors. Like, that's already enough like stuff it's moving around my code, and like suddenly it's like not very easy to write code when you've got all this stuff flying around, which kind of gets back to my local minima thing where you're trying to shove all this information into text and text isn't having it. And maybe we should just be okay trying like a different format to start, because there's a lot of weird things you can do. Like, I'm not really particularly beholden to nodes and edges, for instance. I don't actually think that's, and for a lot of things, I don't think that's the best option. Like, for instance, anything where you've got a chain of nodes, that can just be a stack. That's a much better formulation. But there's other cool things you can do. You can even imagine something with no edges, and there's some visual languages that have like more like ghost channels where like if you kind of hover them, then it takes you to the thing, but like it doesn't necessarily render an edge. There's a lot of really interesting things you can do there that just haven't totally been explored, I think, but are much more suitable.
Yeah, I think what's interesting to me about non-textual, the longer I've spent thinking about non-textual methods of programming, what I found is that my head is in a different place than the whole space. So like, to me, any form of visual programming, I'm now revealing another one of my cards here. Any form of visual programming, I'm like, it is interesting, but I'm becoming more and more convinced that spatially orienting the code is a mistake, and that the problem with text, not the only problem, but one of the problems with text is that it has spatial components that need to be obliterated, not that they need to be reified.
When you say spatial, you mean two-dimensional?
Yes, but also just any dimension. You could put it in 3 dimensions or something like.
But not one dimension. You like the fact that it's vertical, like it's like a single dimension, but once you start to put stuff out over here.
No. It's not even one dimension. What I mean is I didn't mean to open up this can of worms too hard, good. But the interesting thing here that I go back to a lot is most of the things that I long for that aren't there, and this isn't quite, so I do visualization is one of the things I really want more of, and so the nice thing about visual programming is that it generally goes well with including visualization in the mix, and so that is the part where whenever it can work, it is good, but I'm becoming more and more convinced that if you take textual programming and make it more about placing things in space. Actually, I'm going to back up and try to explain this a different way, because I'm realizing that I'm going to assume everyone's had the same thought I have.
It sounds great, yeah. I'm ready to respond, too, because I've had these same thoughts, so I'm excited. It's good.
Cool. So there's this funny thing that happens, another ick factor that I think a traditional programmer has when they think about a node and wire programming system in particular, which I'm just using as an example, but I think it generalizes to most non-traditional programming things. An ick factor that I think that they have is the idea that, like, why does the XY position of the node exist? Why does it matter? Why is it remembered? Why is it persisted? Because, like, it's going to be compiled away. It can't possibly be relevant to the computation. It's almost inappropriate that extraneous data exists in the representation. But then I was thinking about this just like today as I was writing some C code, that, like, my function exists on a particular line of the text that is irrelevant to the semantics of the function, right? Like, it does this, and that's when it occurred to me. I'm like, this has irrelevant spatial data embedded in it still, and I'm not necessarily. I'm kind of saying that I agree with both sides or disagree with both sides. I think the to some extent the irrelevant data that gets compiled away is fine. Like, it's like that's a part of creating an interface to a human, and the compiler compiling it away is like is what a compiler is for to some extent. Like, its purpose is to take it from the accessible interface to the raw compute structure of the thing. And at the same time, a lot of the magic that I feel is missing that I want more of is the ability to sort of use the space of the interface in new ways that are kind of precluded by the fact that space is already taken up by the data structure of the interface, right? So, like, if you were talking about the idea you had about, like, putting the texture next to the GUID, but it's like, but that's going to overlap text that has to go in the same spots. Like, the space is already used by the text file format. And so, yeah, this is just, the whole idea is, to me, what I want is almost a more abstract data structure as the core interface rather than a more spatial one. And so, yeah, that's kind of where my head's at.
This is a great question to dive into, and I have so many thoughts. A lot of them are unresolved in the way that, like, I've had lots of ideas, and I'm only now slowly being able to try some of them out when I allow myself the time. But yeah, really, this is the question of how do you design the UX for not just a programming language, but like a programming thing. Like if you abstract up one from, like, the concept of a text language, like, what information should we surface and how? I think one of the things that visual programming languages suffer from is information density. So text is a lot. It's very dense, like, relatively speaking, and that's great because you can have it on your screen and you can read an entire algorithm on one monitor screen. And then you go over to visual programming language land, and, like, it's 2 to 10 times less dense often, just because it's got padding and borders. But also, like, if you do a nodes and edges thing, then, like, you need some space for the edges to flow. One of the things that I think, to your point about the position not mattering, I am frustrated that more visual languages don't have automatic layout. Basically, they all require you to put things down, and then you want to insert a node between two nodes. You've got to, like, move the nodes out of the way. Like, it's absurd. Like, in text programming, you enter a new line. Like, it's actually kind of wild to think about the idea of inserting a line being, like, a fundamental UX primitive that isn't necessarily a given. But if you want to insert a node, it's like, I guess the other nodes should, like, scoot out of the way, I guess, like they would in a text editor. Like, those kinds of things. Automatic layout on a graph is a very interesting problem and is actually, like, somewhat unsolvable, but I think, like, with heuristics could be done well, in the same way that, like, automatic code layout is very much up for debate and very hard. It's like there's no one true way to lay out C code,
right?
But at the same time, the trend is now to write auto formatters, and most people are, like, generally pretty okay with picking an auto formatter and tweaking some settings, and it doesn't always give you quite the right thing, but it saves you a lot of time. And I think that's what we need in the visual programming space too, is, like, I don't want to think about positioning, please do it sensibly. and I'll be okay with that. But I haven't found any tools that actually do that, which is disappointing.
Okay, interesting. This topic. So this topic of what is it about visual programming that runs into the information density problem, and also how could, well, specifically with the nodes and wires example, how could a format or an editor for something like that be made to be good, whether it's auto layout or whatever the solution is, so that inserting a line, so the magical new space can materialize rather than you having to move all the nodes around. I think it's an interesting topic, and you mentioned earlier something that I think connects back to this, which is that you want Vim controls in your graph editor.
Yeah, I
want to hear more about that.
Yeah, this is a pipe dream. It's sort of a like. I don't know. Maybe if I build it, they will come. Maybe that'll be the right format. It's basically like if I force myself to add Vim hotkeys, like that's going to result in a cool editor. But the point is that for me, the holistic idea of having that constraint is to force you to design an editor that is efficient to use with the keyboard. And I think there's a lot of values to the sense of a grid, for instance, that text comes with. I don't think that needs to be dispatched with in visual editing. It often is, but like we definitely could have a grid, and that would make things way easier. The way that I imagine Vim hotkeys kind of working is most of the time like where I'm going in navigating around nodes. Like generally speaking, jumping around could be very sensible. Like jump up two edges, right? Like two K, right? Jump up, right? And then like insert node on port and then put the port number and like that kind of stuff. Like when I describe it like that, that's going to sound insane. And I don't think that should be the literal interface. There's a lot of really interesting Vim plugins that I love. I think one, it's called Easy Motion, or there's a bunch of different ones. They're all called the same. They have different names, but they do the same thing, which is allowing you to jump to any place in the text buffer with a hotkey. So you hit the jump key and it then spawns a bunch of letters all over your screen, and then you can jump right to one of those points. There's a lot of weird, I don't know, like manipulation sort of tools we could build. But yeah, to me, part of this is about setting ourselves the goal of making that something we care about, because so far I don't think anyone does. But I think that kind of thinking is necessary to get to something that is actually useful and competitive with like the information density of text. I don't know. Does that make sense?
Yeah, kind of. I think it strains. First of all, I don't know the Vim commands, and to me, the Vim commands are
arcane.
Yeah, it's arcane. Like
Yeah.
I wouldn't even edit text that way. So in a way, it's like it's out there, but it is interesting to think about. What are the commands that are possible for automating the editing here? So like, if you could imagine brain dead text editing, which is like, okay, I need to insert a line, which means I have to go to the bottom of the file and create a new blank line and then manually copy the text from each line down one. Right.
Yeah, exactly.
And
that's kind of how visual editors
I could
are.
build that. Yeah, I could build that for you and give it to you and be like, look, text editing is the lingua franca. I am sorry that editing it is such a pain in the butt and you have to manually lay things out all the time. But this is the way it is. Or you could just build one that's like understands these ideas, like, automatically indenting, inserting lines. And it's interesting to think like, what are the primitives of spatially laying things out? Like, can you just say like, okay, I'm inserting a node here, so everything below this needs to shift down to make space. On the flip side, I could imagine working on a tool like this, and it starts to, the spatial relationships are more complicated now in some ways, because I could have two things which are sort of siblings in the sense that neither of them depend on each other, and they might share upstream dependencies and downstream dependencies, but they themselves are independent, so they are parallelizable with respect to each other. But they might be super relevant to each other still. There might be like reasons why they're related, and so I might intentionally want them near each other and almost side by side.
Yeah.
If an auto layouter doesn't know that matters, it could just start shifting one of them down because I'm inserting nodes and break the visual planning
Yeah, exactly.
I did, and that would suck. So Yeah, it's curious. I'd be curious to know more about how keyboard controls work out there, I guess.
Yeah, I'll fill you in when I get to implementing that. I mean, I played around with it a little bit in the Rust version. So the Rust version does have auto formatting in the editor and has some light Vim hotkeys,
Mm-hmm.
not fully to the level I'd like. But and you do have those sort of problems where it's like with a full auto format. Yeah, it's like you'll be editing something, you'll drop a node, and then like whoop, like a node just disappears into the ether because the formatter's like, I think it should be down here now, and you're like, thank you.
Yeah.
But that's also to me, it's like more of a problem with the fact that the layout system is designed not for editing. Like if you look at a code formatter, it doesn't parse your code into an abstract syntax tree and then from that raw abstract sense just relay it out. It really just looks at how you've laid out the code and makes some adjustments. Like
Yeah. Again, with the experience of writing a text editor, the only place where you have freedom and safety to play around with is the leading white space of a line. Like that's where you have flexibility, and that's also where people want the automation. And I think that that's not an accident. Like the where people want automation is sort of a part of the question. So like
yeah,
I guess since as a person who doesn't spend enough time doing node and wire programming, I'd be a bad person to generate ideas about where I want automation. But my guess would be that that's probably where you're gonna find the wins. Like you're working on it and you go, oh, I just needed to automatically know these ideas,
yeah.
and not do because yeah, I can imagine if it's doing full relayout.
But I mean, there's ways to
Yeah.
like sort of give it that information, right? Like you can group nodes together and say like, hey, these are all holistically one concept. And in a lot of node languages, that's a bulky thing to do. But you could
Mm-hmm.
imagine it just even being invisible. Like maybe they're just all like lightly colored the same color or something, right? And it doesn't have to be this big box that's surrounding them all. But
Yeah.
you can do that. I also imagined something where oftentimes there are edges. There's data in the graph that is more important than others. Usually there's a concept of like, hey, this is my main value that I'm sort of like manipulating, or a couple of those, and then I have associated values that I'm calculating that are sort of like secondary things that are informing my main calculation. And I think it would be interesting to allow you to be like, hey, these wires or these values are more important than others. Please prioritize them when you're laying things out. Things like that.
Yeah, I'm gonna. And what occurs to me is taking sort of inspiration from games like Factorio,
Mm,
which bear some strong relationship to node and wire programming systems. A common pattern for dealing with the complexity of layout there is to have a bus where you have a big cable, kind of like
yeah,
a bundle of cables coming down. I'm translating, so in the game it's conveyor belts, but if this got translated to wires, then you have a bundle of
yeah,
wires that would be a bus, and
yeah,
then you'd like pull things off of it and put things back onto it. And I've never seen anything quite like that. That's like lets you construct a bus.
yeah.
Uh,
That is definitely something I've stumbled on before. I haven't seen a language that lets you do that, but the automatic layout library I was playing with called Y-Files. This is like a sleeper library that underpins almost all graph layout tools. Like it's just like this one little company that makes a really good auto layout library because it's a really hard problem. Uh, they provide a bus system, and so I played around with that a little bit. I think it could be useful. I'm very excited to expose these things to people to see how they respond because I haven't used it formally. My intuition is that the bus system would lose some information. Like when you
hmm.
start commingling wires together, part of me feels like maybe you just better off not have them. Like the and I think that we should be more comfortable with that in nodes and wire languages. Get rid of the wire, put a little nub on the input, and when you hover it, it tells you where it goes, or even just always renders out a name. Like I mean, like text code is that, right? If you have a function and you call a variable, like it's like a hidden wire basically, and it's
Yeah.
fine. You remember where it is. And I think that we could do more of that, where like only the important wires are shown. But yeah, once you put things into a bus, I'm not sure if that sort of like sloshes all the information around in my head. I wonder if I
Yeah.
would want that.
No, yeah, it might not be any better than the same thing with but like you probably get to a situation there where it's like, well, now I want to label each wire and grab them by. It's like, okay, I've reinvented variables at this point.
Yeah,
So,
yeah. I
um,
mean, the buses kind of remind me though of like oftentimes I want to visualize what's the data types of wires, and I've been experimenting with this too a little bit. Like, how do you like? There's some objects that are like numbers, which are pretty light, and then there are some things that are like big structs, and then sometimes you have like really big structs, and like with those really big structs, often you're pulling things off of them because you just need the one field on them, right? And there could be value to rendering that structure into the diagram so that you can have a little bit of intuition, like, oh, there's my config struct, and here's my little associated values, and that kind of stuff might become more apparent. And I could see a bus looking thing kind of helping represent that.
well, I think we've covered most of the questions I have on the top of my head. There is one question that I want to get into a little bit, which is developing this. If someone listening to this is going to take something away, I want them, besides what might be cool about a future of coding that is not purely textual, the other thing I would like to sort of give to the user is some insights into how a big long-term project of 5, 6, 7 years, how it like how you keep going with something for that long and like making things work over time. So, you gave us the initial idea was a game engine build graph. Are there points along the way where you can point to that are like, here it came to a crossroads where it's like drop it, or this new idea gave it new life and it can't, like, how does it keep on going and keep being meaningful for
That
that long?
is so. That's such a good question. Because I remember when I started this project, I was like, I had this little concept in my head. I was like, I want to see more like 10-year projects. Like, I think oftentimes like there's a lot of great reasons to fail fast, make the prototype, just get it out there. It does get us stuck in those local minima a little bit, and I really wanted, and still do, I still want to see more people really really trying something and being like, no, this is going to take a long time, and like we're going to do it right and like figure out what's going to be interesting. That was like 6 or 7 years ago, so it's like every year that passes, it's like, oh yeah, this. I mean, at that point, when I say, oh, it'll be a 10-year project, that basically sounds like infinity, and now it's like, oh boy, like maybe it's going to be a 30-year project. Okay, I'm not sure how I feel about that one. So it does get stuck, but I feel like at some point, once you're 5, it's sort of part of your identity at that point. So like you can't give it up. But I think it's also, for me, this project specifically is unique. Like I don't have many other things that I've worked on this long, and it's because I just feel like it's so much better. Like when you have this system, like it's like I just want it so much. Like every time I use normal coding, because I've done this thought exercise, I imagine, how would I put this together in Lattice? Just like various theoretical sort of structures, architectures. And every time I come away with being like, God damn, that's so much simpler. Like, and also like way more debuggable. And like, I just like, it feels like such a major improvement to how we work with things, to not have to catch values and just be able to see things straight on the page. Like, I just really want it. I don't know. That's I don't know. Maybe I'm not sure if that's a good reason to do it.
Well, we could come at it from another way, which is, have there been any points where the main idea had to shift? Was there things about the initial ideas that were wrong, and how did you get onto the right track? Because there are there are usually two kinds of projects that I've been on that have lasted a long time in my experience. There's one kind is on day one you captured lightning in a bottle and you spend years trying not to corrupt that while you throw stuff on top of it.
Yeah.
And then the other kind is like you spend 2 or 3 years kind of like painfully chipping away at something until finally a little magic starts creeping out of it, and you're like, we actually are doing it. This is working. Cool. What kind of, maybe you could start with, what kind of project has Lattice been?
This has definitely been a lightning in a bottle. Like I had that, there was like a month of furious theoretical scribbling, and I have a whole journal of like boxes and wires and algorithms and axioms for this like as a formal system, because I just sort of like it just all flowed out like kind of, and I've spent the last 7 years attempting to capture that in a thing that is physical. That's kind of been the process, and without corrupting the magic. That's a really good way of framing it, because yeah, like when I went to make this version in Unity, like I specifically chose to like not make it. I lopped off a lot of beautiful pieces, but that's because now we are in a pragmatic phase where we're like making a game, and the game is very much that, where it's like, yeah, you baby steps, you work slowly, and eventually you create beauty out of this like slow, painful squeezing blood out of a stone sort of a thing. But the design of this project for me, I think what part of what drives me is that lightning in a bottle. Is it's like I can just feel it, and like feel this idea that I had, and I just need to see it to completion at the very least. Like maybe it's not the perfect system that's ever been made, but like I haven't seen it before, and I really desperately want to be able to use it.
Yeah,
I don't know.
I think that's I think that's probably as good of an answer as I'll get. It is tough because it's got you're generalizing it to any project.
Yeah. Yeah, I wish I had like I think what you're looking for is what were the hurdles? Like, tell me about the problems. And I mean, like maybe like I implemented it first in TypeScript, and then I moved it to Rust. And like I guess that could be a hurdle. Like it was way too slow in TypeScript. TypeScript is awful. But is that a hurdle, or is it just a transitional?
Yeah, no, it sounds like maybe the project has. Well, here's a totally different question. Given how much I've heard about it, it doesn't sound that complicated. Not that it's not really interesting and stuff, but like the core idea sounds simple enough. So why is it taking so long? Like not to jab at you. I'm just curious. Like what has your time been spent on?
Yeah,
and it's partly a part-time project, but why is it a 7-year part-time project?
There's a lot of theoretical underpinnings that I haven't explained, and part of this project for me is allowing myself. For most projects, I don't allow myself to go really deep, to really rabbit hole on something. And this one, I explicitly at the beginning, I was like, I'm gonna let myself rabbit hole. It's part of what I was telling myself, and I was like, it's gonna be a 10-year project. I'm gonna go as deep as I can to build a like vaguely formal logic for how this all works, and I'm sort of coming back up from the bottom from that trough. So like the first year, I mean, it's been very part-time, like to be clear. This is like after hours work. It's not never been full-time on it. But yeah, so like the first couple of years were spent like formulating how this would work. I built a prototype in TypeScript, showed it off to some friends, and like got some feedback and explored that. Then I was like, okay, time to do this properly. I'll do it in Rust. And Rust is all functional, but it's not finished. It was a little too ambitious. Man, that's a good hurdle. I think the Rust one's too ambitious. Like it attempts to implement the full. Gosh, how to describe this? And the Rust one it's very ambitious because it implements it almost on like a mathematical level. I was talking about these lattice structures, and there is a formal theory in there of how that works, where you need mathematical expressions with provable closed forms, which requires a mathematical logic that has that property. And you need things like infinite streams of values. And I was even going to make the whole thing is currently implemented asynchronously. So the whole thing executes in parallel by default. Playing with all those ideas. And you can get you can get strung up in a knot on that for ages. The part of why you're hearing about it now is because I eventually was like, okay, we want to use this in Unity in C#, and so forcing myself to make something that's actually usable. But the Rust versions, it's like nowhere near usable. It's like firmly a research project.
Gotcha.
But it doesn't get to your question of like hurdles.
No, I think that totally answers the
and
question,
maybe that's an inherent hurdle. Like,
yeah. It sounds like there was nothing in particular I was looking for. I was just sort of digging for different nuggets in there. And I think the piece that I just heard that is kind of interesting as like project was not project management, but just when you own a project that's especially a personal project and you're making a call about where to spend the time or whether to keep going with it. There are times where it gets really complicated and it can feel like, yes, the original idea was this magic, and now I'm trying to figure out how these infinite streams work in the closed mathematical expressions. And what's curious about it is like, I don't know what your take is on this, so you should correct me if I'm wrong, but I could imagine myself going through that and coming out the other end feeling like, while there is no working Rust version now, it was all necessary to make it possible to make, like, once you go to do the pragmatic thing, if you've spent all that time wrestling with the formal logic and seeing where it breaks all the ways it breaks down and is imperfect, then when you go to make it pragmatic, it's almost like you've been going to the gym and lifting weights, and now all you have to do is go for a walk to
that
finish.
Is exactly the Lattice version that is in Unity came together in months. Like I sort of just like blurted it out because I was like frustrated with the anti-component system, and so it was very much that. It's a really good way of putting it, because the way that I implemented it in C# is so deeply informed by the Rust version. Like I specifically was like, okay, no infinite streams. We're gonna make time is going to not be a generic value. Time is just going to be part of. We're gonna, build that as part of it. We're not going to worry about making that generic. And there's still also there's a lot of concepts that I did take, which are around how to implement previous references, like things like looking back into the past, or how to represent sliding windows over past values. Or there's like a lot of stuff that just I lifted directly from the Rust version, the sort of the formal one. And yeah, it's kind of empowering in the way that you're saying. Like it is like going to the gym, and like then I have a friend I was just chatting with. He's on his 5th query language. He just like he says he can't be happy unless he's writing a query language of some kind.
Yeah.
And like, yeah, I can kind of get that feeling now that this is the 3rd implementation where I'm like, okay, I got this. I've kind of gotten. I'm even lifting algorithms. I just borrowed an algorithm that I wrote in Rust for calculating some properties over cyclic graphs. I nabbed that from the Rust version. I was like, that's exactly what I need. I'd spent like several days puzzling over that in the past. So yeah, but it is kind of like a tricky thing. It's like, well, will that perfect version linger, as all research projects kind of tend to? Like, but maybe that's okay. Or maybe I'll go and I'll make another pragmatic version that is somewhere in between and is,
Right. Cool. So, I think we've talked about it as much as we can in one setting. You have blog posts coming out soon, right?
Yes, I am working on them. They are coming out.
Is Lattice something that people besides you are going to be able to use at some point or already, or?
So we're using it inside my team. The goal is to get it usable by the people for sure. So I'd like to release it. So it's Unity specific right now, the Lattice Unity one. The Rust version is on GitHub, but like, if you're really interested, you can go play with it. But yeah, the Unity one is usable. It's a package. You can just install it in your Unity project, but it's not currently released, and we're trying to figure out exactly how to approach that. I'm not explicitly building it for other people exactly. So, and there's a maintenance burden that comes with any public project, as I think all open source
Yeah.
like maintainers know. And I'm a little hesitant to like open myself up to that can of worms of like, now I'm supporting 100 people trying to use this thing. So more likely it will be released in a sort of like throw it over the wall, like please have at it, like do it do with it what you like kind of way. But my goal is to release it and to make it. Yeah. There's a Unity thread on the forums where I'm kind of updating folks, and we'll eventually post a build.
All right, amazing. I'll make sure to put all links to that. So if anyone's listening and you wanna check out the Lattice threads on Unity, you'll be able to do that. And if people wanna see other stuff that comes out from you, blog posts or things you've already, where should they go to find that?
Yeah, so my blog is the best way to follow me. You can subscribe on RSS and email, and then if you like, you can also follow me on Mastodon and Blue Sky and Twitter, all of the socials.
Awesome. All right. Well, thanks so much for coming on. This has been a lot of fun. I'll probably have you on again someday to when Lattice is out and there's more to talk about.
Yeah, we could do a YouTube something. You can actually see it.
Yeah, that would be good. All righty.
Well, thanks for having me on.